All right. So let's go ahead and get started. This is Introduction to Firewalls Masterclass. The idea of this course is to give everybody an introductory view into different firewall technologies and to focus on specific types of usages for each one of these types of firewalls. Now, it is important that we cover a good basis of these type of technologies, as they are pretty vital to cybersecurity, especially in today's environment. Okay, the outline of what we'll be talking about, we'll do a small introduction, which we just did. We're going to talk about why firewalls matter, some of the types of firewalls that exist. That'll include packet filtering firewalls, stateful, next generation, some types of things to consider when we're deploying firewalls, some of the use cases recently that have happened, and what could have been prevented with proper use of firewall technology. And then we're going to talk about some of the management and maintenance of these type of firewalls. Okay, then we'll have a small Q&A session at the end if anybody's interested in asking further questions. Let's go ahead and get started. An introduction to the topic as well is, what are firewalls? In essence, firewalls are network components that act as kind of like a gateway or some kind of barrier between the external network, that is the rest of the world, and your internal network. All computer systems need to communicate over network connections. So to monitor and kind of control what is allowed in and out of your network, it makes a kind of border gateway between your internal network and your external network. This seems to be one of the most important network appliances or virtual appliances that you can deploy in a network, as it really is the first line of defense for all types of attacks, cybersecurity wise. Something important to note is the importance of firewalls is because it plays such a crucial role in protecting the organizations from a lot of different types of threats. Most types of threats are not physical threats, which means they don't attack networks directly on their infrastructure, physically having access to them. They attack them virtually through these kind of network connections that firewalls are meant to help protect. Now, what are we going to be covering today? We're going to be covering a lot of different things throughout this masterclass. We're going to talk about the fundamentals of firewalls, exploring the different types and functionalities, and management practices. By the end of this, you'll have a really good understanding of how firewalls work and their significance in cybersecurity. So why do firewalls matter? Well, firewalls matter for a lot of reasons. Since everything is interconnected in the public domain, that is the internet or the web as you know it, there is basically an omnipresent threat that is all over the place. Since everything is able to be reached to anything else globally, in essence, firewalls act as the only primary protection for other networks getting in to your network and either stealing data, modifying data, or just taking down your services. This stands as one of the most important appliances for that exact reason. So what are some of the threats that firewalls help protect with? Well, they do not protect against everything. There is a lot of different types of cybersecurity attacks, but some of the most prevalent ones are the types that firewalls are most effective at protecting. So we have a DDoS attack. A DDoS attack, in essence, is where you have an infected, you have a virus or some kind of malware that has infected many different computers simultaneously, and they basically run scripts on those computers to execute a coordinated attack against a public endpoint. It can be even a private endpoint. A primary example of this is something like Facebook got attacked in 2000. One of the worst attacks was Facebook got attacked in 2014. One of the worst DDoS attacks in history. This was due to a very large botnet, which is what a DDoS utilizes to attack. And proper consideration with firewall configurations could have prevented something like this. Intrusion attempts, if somebody just randomly throughout the internet wanted to connect to your devices, if your devices have internet access in some way, that means you can get to Google, you can get to things like that. In essence, anybody can connect to you if there is not some kind of firewall or other similar device in place. Malware infections, certain types of firewalls also allow us to inspect the traffic that is going through them, and we'll talk about this, but it allows us to do a deep inspection of what is actually passing in and out of our network, and sometimes it can even identify whether the code or the actual information that's being passed matches a signature for malware. This is very vital to just stop it from getting into your network at all. Data exfiltration, same thing. If somebody was already able to get into your network or maybe have physical access to your devices, it's important to stop data exfiltration, which is the exporting of data into another network or into another person's possession. We want to stop sensitive data like social security numbers, bank information, things like that from ever being able to leave a network. So some types of firewalls are able to identify when data is being exfiltrated that shouldn't be exfiltrated at all. And then finally, we have unauthorized access. Even if a network connection is able to be initiated to your network, sometimes you can set rules on firewalls to stop these kind of connections that are from authorized sources. That can either be a location that's unauthorized, or it can be a IP range that is unauthorized. And you can ask for additional information as well to stop certain people from connecting to your devices on your internal network. So now that we understand a little bit about some of the different types of threats that can protect against them, we'll break it down into the different type of firewalls that are available in today's market and which one are better at protecting against what types of threats. Some of them are cost efficient and some are more expensive, some are more versatile, and some are just good at what they do. There's definitely quite a long list of firewall technologies out there, but this covers some of the major ones. The first one we're going to be talking about today is going to be called a packet filtering firewall. Now, packet filtering firewall is basically one of the most common types of firewalls that you'll ever see. A packet filtering firewall operates on many different layers of technology. That means that when computer systems communicate with each other, they basically do it in a layered system where imagine you have a box that is addressed to something, and then inside that box, there's another box inside of it addressed to something else. Each layer of the network basically can communicate depending on where it is in its transmission. Packet filtering firewalls kind of work at a few different types of layers, but primarily they work at layers that are dedicated to ports and IP addresses. IP addresses are kind of just like normal addresses, as in like on a map. It just tells you where things are and how to get there. So with packet filtering firewalls, we can set rule sets on them that allows us to limit what IP addresses and what ports, that means what type of applications they're trying to reach on the network, are allowed in and out of that network based on a rule set that we define. Now, packet filtering firewalls do have limitations and advantages. Some of the limitations of them is they are very simple. Their simplicity is one of the best things about them, but they are simple. So all they do is look at the address information from where something is coming from, where something is going to, and what they are trying to connect to, or what type of connection they are trying to make. Beyond those three criteria, there really is nothing that a packet filtering firewall is able to do. This is good because it makes the implementation fairly easy and its security pretty robust, as in it cannot be gotten around very easily. But there are some disadvantages. A lot of more advanced types of attacks will go right past a packet filtering firewall, kind of acting like they are coming from somewhere else, wherein indeed they're actually coming from a malicious source. So they can kind of be duped or fooled fairly easily due to this fact. So there are some good things. They're cheaper, they're easier to implement, but they are not really the best protection for more advanced threats. You have stateful inspection firewalls next. Now, a stateful inspection firewall is a little bit more advanced as it has some of the functionality of a packet filtering firewall, but it knows the state of a connection. To explain that a little bit, you can imagine that there is a conversation that has to be had before packets or data is transferred between two sources. So what that looks like in essence, sometimes it looks like in the form of a what we call a handshake. If you have two machines, machine 1 and machine 2, for a communication a lot of the times to happen between these two devices over a network, machine 1 will ask machine 2, hey, can I start to transmit to you? Machine 2 will then respond back to machine 1 saying, yes, I am ready to be transmitted to. It'll say, I'm about to transmit, and it'll say, I acknowledge that you're about to transmit. And that's actually when the data starts going through this kind of communication. This is called a three-way handshake after the initialization. Now, the data that gets transferred after that could be sensitive data or something that we have to be concerned about or worry about. So we have to make sure that the communication is in the proper stage before we allow these kind of communications to happen. A stateful inspection firewall allows us to look at what stage in these communications that they were at. We call these states of the connection. So this is why it is called a stateful inspection firewall. So for instance, I can craft a communication that says, give me a piece of data, and act like I'm already in the middle of a conversation with a service on the other end. For instance, I could ask for a document to download some kind of document with sensitive information on it. But the stateful inspection firewall can realize that I am trying to skip steps in the connection process, seeing that I'm trying to start at 2 or 3 in the handshake, saying, okay, this is not correct. You have not initialized connection with me. Therefore, I'm not going to do anything with you. I'm going to cut off the communication. You have to go through the proper steps of authenticating to my network and communicating with my network before I'll let you just start passing data back and forth. The advantages of something like this, it provides better security than just the basic packet filtering that we talked about a second ago, by considering the context of the communication that's happening between those two devices. It is more resistant to things like IP spoofing or faking what your address is and where you're coming from. In a normal packet filtering firewall, I can just say that I'm coming from somewhere that is authorized and then just take the data after that. A stateful inspection understands that it is not coming from that source, or it is in the wrong stage of the connection, because it has verified that it started in the middle and not in the beginning, to verify actually where it came from. So this is something to, some benefit of using a stateful inspection firewall. Some of the limitations of this type of firewall may be more vulnerable to sophisticated attacks, like exploiting firewall weaknesses, vulnerabilities, and certain types of spoofing also do not work with a stateful inspection firewall. Some of the other things is it may require a lot more resources due to the connection state tracking. So not every type of server or virtual machine can run this type of firewall, because it is a lot more taxing on resources. It has to do a lot more data processing very quickly to not slow the network connection down. So it can be more expensive to operate. It can be a little bit more cumbersome or complicated to set up, but it doesn't mean that it is bad. It just has trade-offs as anything else does. The next type of firewall we'll talk about is what's known as a proxy firewall. Now, proxy firewalls kind of come from a different type of technology known as a proxy, and proxy firewalls were kind of integrated with this. To kind of make this make sense a little bit, the term proxy means to do something on behalf of. So again, with the example that I gave before, if I have a device 1 and I have a device 2, I could just let device 1 talk to device 2 directly if I wanted to, right? That's how a lot of communications work. Device 1 just talks to device 2 right away. But instead, to make it a little bit more secure, I can put a proxy firewall in place, which means that if I wanted to talk to device 2 as device 1, I would have to send the communications to my proxy firewall as a middleman. And then those communications would then be forwarded after it is verified that the connection I am trying to make is okay. It is taking the same kind of things that a stateful firewall does, that is like the source IP address, the destination IP address, the source port and the destination port, some of those same things we talked about earlier. Sometimes even the context depends on the type of proxy firewall, and it verifies that I'm allowed to make that connection. And then instead of me actually doing the connection, it makes the request on my behalf. The reason for this is because when device number 2 responds, it won't be responding directly to me, because the source of where the communication came from is from this firewall. So it'll have to filter or send the information directly back to this firewall, in essence, then to send the information back to 1. Again, having to go through that rule set that was implemented on this proxy firewall, it basically forces the communications to go through that, verifying everything and not allowing anything to directly connect to anything else. Proxy firewalls give us a lot of good things, a lot of good advantages. Proxy firewalls offer enhanced securing by hiding the internal network from anything that's public facing. So if you're on just the internet, you wouldn't be able to connect directly to anything on my internal network because it would always have to hit the proxy firewall and always go through the rule sets. With normal packet filtering firewalls, there are a lot of ways to get around this kind of communication by just inserting yourself somewhere else on the network instead of having to go through this. They can perform deep packet inspection as well by analyzing the contents of the packets, not just for the context of the communication, but for those kind of malicious identifiers to say that something looks like it could hurt or it could have a virus or some type of malware embedded in those communications. Proxy firewalls are pretty effective at filtering out malicious websites as well. There's features on them known as web application firewalls that are usually integrated into a proxy firewall that allow us to basically stop people from even connecting to sources that we know are malicious. Something like goofle.com is a known malicious website. It doesn't allow you to connect to things like that if you don't want it to. So all your users that may have just typed in something incorrectly and they end up going to a malicious site, is the idea you can stop them right there saying you typed in the wrong address. This is to going to something that has malware on it. Some of the limitations, though, there are trade-offs as with anything. Proxy firewalls introduce a lot more latency because they take a lot more time to look at the traffic before they pass it to the endpoint, the second device. They are a little bit harder to configure and to get properly. You usually need people that have been doing it for a long time to configure them properly, as the types and amount of rule sets that come in them are extremely robust. There is a lot of them. And then they may not be suitable for high-speed networks or things that rely on very high, quick connections like e-commerce or data streaming and things like that. We have to rely on a different type of packet filtering technology to do that because the latency would be too high for things that are dependent on how fast they get to their destination. Then we have a next generation firewall. A next generation firewall kind of encompasses a lot of the technologies that we've already talked about and combine them into one firewall. So some of the things that we have is like application awareness. It identifies and controls applications on the network, only allowing not just IP addresses or port addresses, but specific identifiers that applications are running. There are certain IDs and things like that that can be passed or have to be passed for it to let the traffic through. It also has intrusion prevention. It can not only see if something is malicious, but take precautions to stop things that it thinks are malicious in the future. So for instance, if I have some kind of data from device 2 trying to reach device 1 and it hits this firewall, it doesn't find a rule on this next generation firewall that explicitly blocks it, but the firewall does a type of inspection. I'll try and draw a magnifying glass here. It looks at the data and it finds that there is something not good in the data, some type of identifier of malware. It is able to automatically create a rule set on it that says, I identified malware on this connection, block connections from device 2, or block just this type of connections over a specific IP address or port address that's coming into the network. This dynamic allocation of rule sets allows us to not only identify things, write static rules that we've identified as being things that would protect our network, but it can automatically identify things and stop them from happening if you want it to. It also has threat intelligence. It uses a lot of identifiers from multiple different organizations that basically look at the traffic that's going over it and is constantly updated with the newest type of attacks and the newest identifiers of different types of threats that are going over a network or any type of network in their kind of community. So if a threat comes in from device 2, or let's just say device 3, because we bullied device 2 enough, if we have a device 3 that's trying to come into our network and it has a type of malware on it that we have not seen before, a normal firewall would not be able to do that. Something with intrusion prevention would not be able to do it, but something with threat intelligence would be able to look at it and say, okay, it's not exactly matching anything that I've seen before, but there is something similar to my database that I've realized that says that it's not good. So I'm going to make an assertion here saying that although it's not exactly the same, it is similar enough that I have to block this connection as well. I'm not going to let this kind of communication continue on our network for this reason. So threat intelligence is really good. And it also comes with some kind of advanced functions like SSL inspection, which means that if a client is going to connect to my device, device one, we have to verify that it has the proper encryption certificates and things like that to make sure that it is authenticated. It is just another step that's added on top to make sure with a very high degree of certainty that communications are allowed into our network and so on. We have what's called sandboxing, is we can try different types of communications over, and if something is if something is suspected of being malware, it can basically you can look at the malware inside of these type of next generation firewalls and see what it would have done if you did let it onto your network. And then it also allows for network segmentation, which means if I have, and let me just erase some of this a little bit. I need a little bit of space here. If I did have a type of network and I had, let's say, device 2 and device 3 again, if I wanted them to connect to device 1, device 4, and device 5, we can segment our network logically on this firewall. So no matter, even if something was allowed into our network per se, it is only allowed into a segmented portion of our network. So even if it did infect somehow this type of, this device 4 that we have here, sorry for my drawing, this device 4, it is not able to connect to device 1 or device 2. It has not been allowed those connections. So we have this kind of network segmentation that allows it to pass traffic through. If you want to think of it as lanes, you can think of it that way. This kind of network segmentation, although does not necessarily stop an attack, it can definitely minimize the impact of something that is able to get through. Some of the advantages, as we talked about with a next generation firewall, is to protect against the various types of cyber threats that we have, including malware, DDoSes, spoofing, and things like that. So it's very advanced, very good at detecting almost any kind of attack. It's basically the forefront of all types of firewalls. It has application visibility, so it has a lot more information about what type of traffic should be traveling over the network, depending on the type of applications that we're using. It has scalability and performance. It can scale for very large networks and very high data loads that would tax it under very high performance means. So it doesn't exactly slow down all the time. Depends on the situation. And then it has a simplified management. A lot of these things have web consoles or web UIs that you can log into and manage them in a lot more easy way. A lot of firewalls actually do not have kind of graphical user interfaces that you can click buttons and see drop downs and things like that. A lot of it is actually done straight through the command line. So this offers us a very nice simplified management console to automate our policies and to write policies and manage the device. Some of the limitations of a next generation firewall is they can be extremely complex. No matter what type of next generation firewall that you're using, you usually do need some kind of specialized skills for proper deployment and management. Some examples of firewalls that are some kind of companies that provide this is Cisco, Fortinet, Palo Alto, and F5. All are things that can provide next generation firewalls. All of them are pretty much the same complexity though. And then the initial investment in a next generation firewall is going to be quite more substantial than a traditional firewall would be. But it depends on what your situation is or what kind of data that you're using or what is the use case for it. And we're going to talk about some of the considerations here in a moment. Some of the firewall considerations to have is where we're going to place it on a network. Now, deciding where you're going to place it might seem like the easiest thing. It might just say like, we'll put it outside of our network. The problem is that when you have a network, you have a lot of different subnetworks inside of that network. So we'll have, and I'll just make this kind of simplistic, we'll have a HR division in our company, perhaps. We may have a finance division. We may have an operations division, things like that. All of these networks have to be communicated with much different things. So maybe HR has no reason to go out to the internet. Maybe the finance department needs to. Maybe the operations needs to talk to the HR, but they don't need to talk to finance. There's a lot of interconnections that happen that we have to determine where the best placement of a firewall is. A lot of the times it is indeed what you think is that we have the internet, and I'll draw a cloud for that because that's usually what it's denoted by. you have a cloud, and we'll just call this the web, right? The World Wide Web. You usually have what's called a trunking point or a gateway point, which is where all the internet connections from your internet service provider go in. And we can put our firewall somewhere where that enters our network, right? Although it may not be the best placement for it, sometimes it's better to put firewalls that are smaller, have a like generalized firewall that we put is smaller or like right in the front where all the traffic comes in. But also maybe we don't trust exactly our network. Maybe ops is actually done by a third company that is not part of our company. All we do is the finance and HR for other companies. So we need to talk to them, but we're not exactly sure how much we can trust their network because we don't operate it. So in those cases, it might be better to just put a firewall between these two networks and just to make sure that the traffic passing between them, and also considerations is what type of networks do we, or what kind of firewalls do we need to implement? Maybe this one needs to be something like a next generation firewall, but ones that are internal to our network can just be packet filtering firewalls, just to make sure that only things that are coming from that network are the type of communications we want to hear. Placement seems to be a simplistic thing, but when you get into more complicated network architectures, it can be a little bit more cumbersome to consider all the factors. We also have segmentation. Segmentation was kind of covered in this same graphic that I drew out, that when we want to segment a network, if we have a firewall, and we have 3 different networks, and I'll just draw it again really quickly. We have 3 different networks that come off of that network. We have to segment the rule sets that each one is allowed. For instance, maybe HR needs to go out to the internet, but there's no reason that the finance department has to go out to the internet. So we have to segment the rule sets. We usually do this by, in the firewalls, there are ways to actually separate different nodes or machines on your network into different application pools or host pools, as you may call them, which means we kind of add a little kind of bubble around it that it only, when it has a conversation with the firewall, that conversation goes differently than if the finance department's machines had a conversation with the firewall. They'll see 2 different rule sets allowing them to go out to the internet or not. So this is the way that we segment our networks with different rule sets, depending on the type of firewall, to allow certain machines to go out to the internet and certain ones to be completely locked down. It's just contextual. Then we have filtering rules. There's 4 main criteria for filtering traffic when it comes in, and I'll draw it out here. The first rule is going to be, where is it coming from, address-wise. So we have our what we call our source IP or source address. And then we have what is known as our destination address. Where is it going to? What is it trying to reach in our network? And then we have a what kind of communication is it coming from? We're going to call this source port. What kind of conversation? And then the destination port. So these conversations have to depend on these 4 criteria. So when we set filtering rules on our firewalls, no matter what type of firewall, they have these kind of filtering rules at the most basic level. So let's say that something is coming in from our HR department in its IP address. It doesn't really matter what the IP, let's just call it, it has IP number, like A is just to represent it without going into the networking aspect too much. We have HR IP number A wants to reach out to finance department's IP number B. Now, finance only allows us to talk to things over port 443. It's a pretty common port that you use to just go to websites. Maybe they host a website of some kind. And then A only allows us to go to something like 21 or 20 to do file transfers. So what this means is if I was to create a rule set on this firewall, that I would have to take the source IP, let's say allow IP A, to go to the destination. So we're going to allow IP B. So we're going to A, we're coming from B, we're using a source port of 21, but that 21 is actually interacting once it gets the firewall, it's going to change it or something like that. Or we can just say we are going to allow, let's say that HR department is able to use 443. Let's say it's going to allow a source port of 443 and a destination of 443. This is the rule set that would be able to allow this machine or this network to talk to this network. Because we're saying we're allowed to come from this IP, we're allowed to go to that IP, we're allowed to use this port that it's using on that network and the port that we allow on our network. These criteria is actually how we do filtering rules. We could say you're allowed here, but you're not allowed to use these ports, or you're allowed to use these ports, but you're not allowed to come from here. All of these can be kind of done and filtered through a little bit more granularly once you're configuring a firewall. You can also allow an entire network to communicate, or just one IP address on that network to communicate. It's kind of at your discretion how much of that you would like to go through. Let me make a little bit of space here. I could have just done that the first time, but either way. Then next thing is we have default deny policy. Some consideration to think about is that when I have a firewall just newly out of the box, all firewalls, most, I shouldn't say all because you shouldn't use absolutes, but most firewalls have what's called a implicit deny rule set on it. Implicit deny. So what that means is an implicit deny basically says that by default out of the box, I am not going to let anything talk into my network. Everything is not allowed. I am going to say no to any connection. And then I'm going to force my network admins to say, you need to tell me exactly what is allowed to come through. And I'm going to say no to everything else. This makes it a lot easier when configuring firewall rules because you should start with nothing is allowed and then just slowly add things that are allowed instead of saying everything is allowed and start one at a time saying what's not allowed, because there's more things that should not be allowed than there are things that should be allowed, right? So to start out a firewall, we have to think about this implicit deny kind of default configuration that it comes out of the box. It may seem like a firewall doesn't work when you plug it in, but it actually automatically denies everything. And that's on most firewalls, almost universally. And then we have redundancy. If you think about it, if all traffic from the internet was going into our, let's call it a gateway firewall or our main firewall, right? And then into that is actually our network with all our different little subnets that we talked about before, HR, ops, finance, and things like that. Imagine if this firewall were to go down, if something were to take it down, whether it's a cybersecurity attack and it got DDoS, denial of service, or maybe just the power went out or something like that. Maybe the firewall's really old and it just finally gave up, finally a component in it broke. All the traffic that was coming from the internet has now been cut off. And this is a completely isolated environment now. So we have to think about redundancy with all our choke points in our network. So in essence, there should be a secondary link that goes through either with or without a firewall. The best way to think of it would be to have a secondary firewall that's sitting by on standby mode in case the primary one goes out. What we call this is an AV set in the cloud, or an availability set. It means that we have another firewall waiting in the wing. So if this firewall detects that this firewall has gone down, and it does this by having a connection to that firewall kind of on the side, it can start assuming the traffic flow from the internet down to the network, and it has a copy of all the firewall rules that the original firewall had. So there seems to be no difference that if the first firewall went down, this one will be able to take control right away and just start passing traffic as if nothing ever happened. So redundancy is something to consider when putting firewalls. Maybe you have the money to buy one NGFW, but you don't have money to buy a second one. So if it goes down, you're completely isolated and you're kind of in the same spot in general. Then you have monitoring. There's a lot of different ways to do monitoring as it regards to firewalls, but a lot of firewalls have push notifications, email, SMS, that is text messages, and things of that nature that allow you to get notified if something specific happened. And you can set up these alerts inside the firewall's interface saying, hey, somebody from an IP address that is not allowed or something that looked like malware tried to connect into our network. This is where it came from. It'll automatically generate those alerts no matter what kind it is. It could be email is pretty much one of the most common. Email your admin team and say, hey, somebody tried to connect. You might want to look into this. They'll look into it and then secure their network if they ever try it again. And then you have updates. Firewalls have software just like any other network device does, or basically any device on any kind of network does, that needs to be updated. And some of these updates can happen automatically if you'd like them to, but most people opt to do them manually on their own schedule. So the problem is that if you do not keep your firewall updated, you'll, with the latest security patches and functionality patches, just like they could attack, just like a bad guy could attack anything on any of these devices, they can actually attack your firewall as well. And just like we talked about before, if they're able to take down this firewall, they're able to just isolate your network completely. So that just seems to be an issue no matter which way you cut it, right? And then finally, we have some of the documentation. There's a lot of documentation from the vendors, and it is always best practice to go to the vendor and look at how they prefer you to write rules and how they prefer you to do different things. But it is always a good idea to do that. It's always good to also keep your firewalls up to date with like how you did your firewall configurations, what firewall things you have in place, and save copies of those configurations. So if somehow they get deleted or somebody makes a mistake on them, you can go back and you know how you configured it before when it was working. I have a question here. It says, is there any advantage or disadvantage of using a hardware-based firewall to firewall software-based firewalls? There is some, especially if you're primarily on premise, most people opt to use a hardware firewall because it's just easier architecturally to like grab the only link that gets into your network, which is from your ISP. We call this a WAN, or a wide area network link. This is actually the cable that actually reaches out to your ISP or your internet service provider. And just plug that into your firewall. And then all the traffic from there has to go throughout the rest of it. So, I mean, some people prefer just because architecturally it makes a little bit of sense. There are some arguments that say that hardware-based firewalls are faster, especially when coupled with an on-premise environment that is an environment that's actually in a physical data center that you manage. So that would be an advantage. A software-based firewall, as far as like working in the cloud, there is no real performance difference, but some people find it a lot easier to manage firewalls because you have remote management features with software firewalls, where it's a little bit kind of not a good security practice to have that with a hardware-based firewall, because that means somebody could go from the external network and go into a physical device on your own network, which is not really great. But there, things like Microsoft Azure or AWS allow us to secure software firewalls a little bit more than you would be able to do with your own personal firewall in a local data center. It's a very good question. So I guess the answer is maybe, depends on the situation. It can be. There are some case studies that we're going to talk about now. These are two case studies that happened recently. One of them is from JP Morgan and one is from Equifax. The background for the JP Morgan case study, and this is all related to firewalls, they had a NGFW that was deployed on their network. It is JP Morgan is one of the largest financial institutions in the world. It's a bank that was started a very long time ago, sometime in the 1800s, I believe, but I'm not 100% sure about that. But they did deploy a next generation firewall to stop threats coming onto their network. And what happened was they did get attacked, and due to the fact that the NGFW was in place, they saw an extremely significant reduction, over 20% or something like that, I believe, in cybersecurity incidents, and allowed them to look at their traffic a little bit better. The NGFW was actually able to stop a numerous amount of different types of intrusions and malware infections and unauthorized access attempts, basically allowing their bank to run a lot more securely. So this was a very good example of implementing something like an NGFW actually has tangible returns in a cybersecurity sense. The second case study is from Equifax. Now, Equifax is a leading credit reporter. So if you ever run a credit score on somebody, especially in the United States, Equifax is one of the three major providers of those credit scores. Now, one of the largest consumers, they had a massive data breach in 2017 due to a critical firewall misconfiguration. They did an investigation into this type of attack, and they had a vulnerability on one of their web servers known as Apache, and it allowed them to basically exploit that vulnerability and gain unauthorized access into where they keep consumer data or people that use their services. Their firewall configuration did not restrict access to their internal systems, which enabled those attackers to actually infiltrate. And after they were able to infiltrate, they found vulnerabilities on things that they could do stuff with that would give them access to what they wanted. So the impact for this was they lost over 147 million individuals' personal information. That is a staggering number of data loss. It is pretty much one of the worst data losses ever. And the breach had a lot of things happen after it, including they had a lot of regulatory committees come to Equifax and basically look into how they were managing their cybersecurity, and found out that they were obviously not doing it enough. They were sued by a lot of people, and they had significant financial losses just due to a misconfiguration that way. I have a question. Are firewalls only applied to networks, or can they be applied to web applications or APIs? Yeah, that's a good question. So yeah, there are definitely certain types of firewalls. We call them web application firewalls, or there's not called like API firewalls, but web application firewalls and things like that can also protect your APIs and so on. So yeah, there's a specific type. It's not covered in this context, but we do talk about it. CyberWarrior, we have courses and things that discuss web application firewalls and APIs and protecting them and stuff like that. So that is a good question. They definitely do. There definitely are protections for those kind of things. And then one of the lessons learned from the Equifax data breach shows that it underscored the importance of timely patch management. Basically, patching the internal devices is obviously always a good thing, but more importantly, to configure your firewall and constantly test your defenses and configure those firewalls the correct way, because it was due to a misconfiguration that let them in the first place. It's not excusing that their web applications were out of date and needed to be updated as well, but it still led one thing to another. So two things that were insecure led to a very massive financial loss for that company. So leading to a lot of changes in their company, obviously. So one of the last things that we're going to talk about is firewall maintenance and management, due to some of the case studies we just talked about. Why it matters is keeping your firewalls updated and well managed is obviously really good. We don't want our firewall to become a liability. It's supposed to protect our network, so keeping it up to date with the most latest security patches is pretty vital. Some of the rule managers regularly review all of our rules to match the security policies, what we're allowing, what we're not allowing in. We could do log analysis. Firewalls connect log information just like any other kind of device does. So it is important, just as we review logs on our normal servers and devices, to review logs on any of those other types of devices for suspicious activity, to respond to them quickly. We can also policy optimize, especially when it comes to things like next generation firewalls. There's really a lot we haven't covered on them in general, because you could talk about the topic for a long time, but suffice it to say that next generation firewalls are also able to take in information or data that's being passed to internal devices and actually change the data in specific ways to allow for a better or more smooth communication between two different devices. So configuration, or optimizing our policies to make the best performance out of them, is really one of the best things that we can do. Keeping our firmware and our firmware up to date, we talked about, is really good. Training people, especially the administrators, to do these activities, to patch the devices, to make backups of the configurations, to review the policies that are in place, is super important. Firewall management. There are a lot of firewall management platforms to simplify the management tasks. Now, they're third-party ones, but most people opt to use the vendor's automated tools, but there are other third-party tools as well. You can make sure that you manage your automated tasks, like intrusion prevention and things of that nature. You can set up your threat intelligence feeds to things that you specifically trust to give you good, reliable threat intelligence information. CyberWarrior also has information on this in some of our other courses as well. And then some of the best practices is following guidelines for the industry and specifically the vendor that you're using. So you don't just want to say that you don't want to make configurations for one type of firewall that may not necessarily work on a different one. Although they all follow the same fundamental concepts, it's important to look at the vendor that you're using and stick with that one. We can always continuously improve and update our firewall and always be testing our firewall for the best type of performance and security metrics that we're looking for. And then obviously we can always collaborate and work with other security teams and network administrators to make sure that the firewall is doing what we want it to, and it's not more of a hindrance than it is a help. All of these things seem to be a very good idea in general. Okay. So to conclude with some of the things that we've talked about today, firewalls are pretty much an essential for protecting our networks for cybersecurity threats. They stand as one of the pillars of cybersecurity in general. We now probably have a good understanding about the different types of firewalls and hopefully some information to help us choose firewalls for what might be a better solution in the future. We talked about the proper firewall deployment, management, placement, and maintenance of all different types of things. Some of the things that we can consider going forward is to implement some of the best practices we've learned here in our organizations, to stay updated on some of the emerging threats, especially as it relates to firewalls, and continuously evaluate our in-place firewalls and maybe think about new considerations for new technologies to strengthen our network posture. I really appreciate everybody attending this masterclass on Introduction to Firewalls. And if you have any questions, feel free to ask them. You can put them in the chat, or you can just say something out loud. It's up to you. I do have a question in the chat. How often should firewalls be evaluated on their performance and functionality? That's a good question. Some vendors say that firewall configuration files should be at least looked at quarterly, and I kind of agree with that. I think that, I mean, you obviously always have to evaluate when it's necessary. So if something is not working, you have to evaluate. But you should at least quarterly look at your cybersecurity posture, and especially annually. Every single year, you know, budgets for companies and things like that have to be drawn up. So at least yearly, you can look through those security configurations and see if your firewall is perhaps lacking in something that could be taken away in a further place. Do we have any more questions for the course? Yeah. Okay. Is there any limitations to apply cloud-based firewalls or on legacy hardware? Well, you can't. I guess it depends. When you say cloud-based, it may mean that like think we got maybe like kind of crossing terms here. If you mean like a software firewall on some kind of legacy hardware like a server, by all means, there's even you can run firewalls on basically any type of device. So for instance, like there's a firewall called pfSense. It runs on something called OpenBSD, which is a Linux variation. You can run pfSense on virtually any type of device at the low end, and then some types of devices can be run at the high end. Even integrated into most servers or some type of like Windows Server, for instance, has by default like software-based firewalls built into them. There's also just straight firewalls that you can deploy as well. There's a lot of different solutions out there, but I guess to answer your question, you can make use of legacy hardware and deploy software-based solutions on them. Doesn't really matter how bad the hardware is. It just is kind of dependent on the type of thing you're looking to do. Open it up to anybody that has any more questions. Okay, I'm going to turn it over now to Clara to talk about CyberWarrior. Clara, would you like the screen or is this okay?
No, that's okay. I just wanted to remind everyone who has joined us today that we are a cybersecurity academy, and we have recently launched a cybersecurity platform where you have, live classes, job placement assistance, master classes like this one, and different training and placement opportunities so you can succeed in the transition into cybersecurity. Or if you're upskilling yourself, then we can help you too there. We have, live support. We have the fact that you can schedule one-on-one calls with job placement, job coaches, with our instructional team, and with everyone else who makes life in the cybersecurity field. If you have any questions, don't hesitate. I will leave my email on the chat so you can contact me, or you can simply go to our website, cyberwarrior.com, to find more information. Thank you all for those who joined us today. We will have a next masterclass the next month. I will keep you updated by emails, okay?
Okay, thank you so much, Clara, for that. Yeah, if anybody has anything they'd like, just feel free to hit us up. We can be contacted a lot of different ways, and thank you for coming. Hope everybody has a nice day. There's the email. Thank you, Clara.